Okay, hi everyone. So, first of all, thank you for the guys from Nexar and to Dan. Like, we've been knowing each other for years, and prior for forming Cognata, I made something which is, I think, similar to what Nexar does. It was an application called Ion Road, and I'm really happy to see that now someone is taking that forward. And Dan made, I think, a perfect introduction to the subject we'll talk about today, like what is good, what is not good, why you need ground truth. So after doing around a decade ADAS, I came to an understanding 2 years ago that the shortage in the industry today is not about the algorithms for perception, not about the algorithms for path planning. It's all become commoditized. The differentiator for real autonomous driving algorithm is the data. And in order to train and teach those algorithms how to see and how to take decisions, you need mountains of data, high quality annotated data, which is diverse enough. And the way to do that is with a simulation. And now we'll show Cognata, which does exactly that. It's a deep learning-based autonomous simulation, and deep learning is not a buzzword, and we'll explain why. So, first of all, about the market, like autonomous driving is happening now, and you see all kind of companies, big companies, starting ride-hailing services or testing their algorithms, but it's still not there. This is like an example of a car from one of the ride-hailing services, which goes out in like 4 red lights. And this is after like 3 years of research, it still had issues. Things are not validated. Same 2 months ago, a shuttle in Las Vegas was launched. It had a very simple route of less than 1 kilometer, dedicated lane. You just need to stop along the lane. And after 46 minutes, it crashed into a truck. Now, this truck made something that they never predicted. It shifted the gear into reverse. The shuttle stopped and didn't know what to do. And people inside the shuttle were screaming, it's going into us. It wouldn't hold, it wouldn't take over, it wouldn't like shift into reverse. Because this is the autonomous future, and this is like what we are like expecting. So we need to test it. I think that's clear. Now how much to test? How much do you need to test? Like, what is the number? Like, can you guess how much testing is needed to get autonomous driving validated to the same level as a human being, not better? So it's a huge number. It's 11 billion miles. It's not coming from Cognata, it's coming from RAND Corporation. They have calculated the statistics of casualties in 2015 in the US. It was 1.09 fatalities per 100 million miles. And they've calculated if you want a machine to have the same performance as a human being with 95% of confidence, you have to get to this number. Now, the numbers that are really driven in full autonomous mode that you can refer to last year are 3 million miles. It's not even a fraction of a percent. So there is like a big gap between the need and the ability to test. Because sending a car out, it's an expensive manual work. Like Dan has mentioned, annotating one image to 60 minutes, impossible. Think about an autonomous car, 12 cameras at least. And you have LiDAR, point clouds as well, and radars. All of them, you need to know what they're seeing. You need to know that there is a ground truth to that. It's impossible. It sums up to hundreds of dollars per kilometer. You cannot like do the multiplication. Get 11 billion, even multiplied by $100 per kilometer. No company in the world can do that. So what we're hearing from the industry is that they are shifting their paradigm into simulation. And and like the balance between annotated data and simulated data that we're hearing is like in ratios of 99:1. Now let's talk about Cognata and let's see how can you make a simulation good enough so it can be mixed up with real data and really improve your performance. So Cognata, to sum it up, has 4-layered solution. 4 layers, simple: static, dynamic, sensing, and cloud. On the static layer, we are building full cities in 3D, and we're talking about real cities, the real stuff. We built parts of San Francisco, Munich, and near our offices in Nestiona. But the thing is that it's not being manual. The way that we did it, it's fully automatic. We're using a combination of GIS data and computer vision deep nets over satellite imagery and street view to create full terrains fully automatic. So here you see the building built on an elevation map. The road network is built in parallel, and the result is a photorealistic scene created in minutes. And the thing is that there's no manual job here. The only manual job that we have with Cognata is to actually go over the scene at the end to see there's no issues. Because there are always issues with the data, and Cognata is fusing more than 10 different sources to create each scene. Second layer, so we created with the static layer, we created an empty world. Now we have to populate it with something. And it better be something real. We're doing real cities. Now how do you put real traffic into that? The virtual agents, vehicles, pedestrians, how do you do that? Today, the way that you do that is by sending autonomous car out, collect the data, make sensor fusion, get a target list, then run your reinforcement learning algorithms on that. It's excellent. The problem is scale. Scale is 0. Not even close to what you need. Doesn't have the variety. The way that we tackle that with Cognata is that we are partnering with several aggregators, and we created something which, let's call it a niche. It's really hard to get the data into a big data problem. We're taking data from fleets, and we know how to analyze their data, and we get localized driving behavior. So for driving in Tel Aviv, we get different prototypes, and for driving in California or in Munich, different prototypes. And it's very localized, so we can tell different cities what is the distribution, how people drive, and we can show it looks quite realistic. This is a simple scene of lane merging from 3 lanes into 2 lanes. There are actually additional factors when you do a simulation. It's not just boxes. Each of the cars, each of the vehicles that we have with Cognata is modeled after a real vehicle with, integrators, real solvers. So they move over real terrain, and there is a calculation to their weight and to their acceleration and torque. On top of that, we have the driver AI. And you see the scene is quite realistic. You see the congestion. You see the negotiation between the vehicles. Everything is very realistic because it comes from real data. Now, even to spice it more, on this scene, it's actually...
Normal behavior. What happened was a crazy drivers. Drunk people.
There was a drunk person there.
So what I like about this scene, it's all the same car, it's all the same driver. It's one driver goes 50 times against himself. This is what you get when you drive against yourself. Now, this is when we kept it simple. Now, when you take real data, it's much more spicier. And the thing with autonomous driving, it's not about driving 80 kilometers per hour on the rightmost lane. It's about the edge cases, the crazy drivers, and we create tons of edge cases with our methods, both for the perception stack and policy stacks. Okay, third layer is the sensing. I was doing computer vision for years. Like, this is my expertise, starting with, the whole stack of Viola Jones, going to deep nets, And I was using ADA simulation. The problem that none of them like made any sense. It looked like a cartoon, like the level of images that were rendered there. And then, you know, some companies came with Unreal and Unity as the graphics engine, much better, but still not there. So we had like a different approach, and this is fully based on deep nets. We're actually using deep nets to doing the rendering with Cognata, and I will explain what you're seeing here. So on the right-hand side, it's a real video from the Kitty dataset. On the left-hand side is synthetic implementation. This is like the kind of things that you were used to see. The details are there, but it doesn't look realistic. Like your kid could tell you that this is like a painting or like somebody, it's not real. Like the trees are not real, the sky are not real. It's not there.
Why you care about the trees? Because they are irrelevant.
So the cars are not there, the road is not there. We have like full environment. Like you want it to be as intelligent as a human being. Like all the simplification that people takes doesn't add up to good system, I can tell you that. Now, what we do with Cognata, we use a kind of a transfer learning method where we learn the actual sensor and learn how to operate it on the synthetic data, and the result is Cognata in the middle. Full synthetic scene, which looks like the actual scene. Now, the thing is that we checked how good it is, how good it will be, how would it be to train a data over our inspired data or our refined data versus real data. And the difference in performance that we have found out after training a network both on the synthetic versus the real data and then testing it on real data was only 5%. And we're talking about simulation. You can create tons of data, different weather condition, different light condition, different traffic conditions. You can get much more data with that.
Simulate just images?
No.
Or just all LiDAR and
Very good question. Yeah. So LiDARs as well, radars as well. And we're doing by taking real data. So the artifacts, the distortions, the false positives are coming from the actual sensor. Physical effects like multipaths and stuff like that are like on our basic layer. When you want to get like to the third and fourth order that you cannot do, you can do, you know, like for a radar simulation, you can do it, but you'll need like a room full of computers and you will get like 1 frame per second. So we are not going there.
Repost the question, please. And then repost the question, please.
Repost?
Repost, yes, I asked the previous lecturer. Okay, just ask the question. What is in California when you have a green on the left turn, but there's traffic across and you have to...
Mm-hmm. Okay, so as we said, like different countries have different driver behavior. And since Cognata takes data from those locations, it comes with the actual behavior. Like I think everybody knows that if you take a car from Mountain View where everything is very ordered and looks like a matrix and put it in Yafo, it wouldn't drive, right? So we believe in that. Like for many reasons, it wouldn't work.
Since you're talking about that, every model has a very few or finite number of parameters. And as humans, as we drive, we have much more parameters. So you train the network to learn the parameters of your model. It seems like that.
It's more complicated than that. I can take it after. Like there's like clustering, there's classifications, more than 100 parameters we can tune. It gets to very realistic behavior. 5 דקות אין בעיה. Last part is the cloud. Just one thing about it, we have announced in CES our partnership with NVIDIA and Microsoft over having Cognata as a hosted solution in Azure. And one thing that we'll show here is how we run it as a distributed platform. So we can support any kind of vehicle. What you're seeing is 4 computers, each of them is rendering a different camera right camera, forward camera, left camera, and rear camera. All of them are fully in sync with a very low bandwidth protocol. And I think it's not for computers or for cameras. You want 12 cameras in a real vehicle, 16, we support it. You want 2 LiDARs, 10 LiDARs, we support it. All the ground truth created automatically. All the bounding boxes, semantic segmentation, depth maps, you name it. We have it. And the quality is 100% accurate.
Each sensor needs different computers?
No, just, we had to make the point, but, it's depending on, the performance level of this PC. I will take at the end, so we have like 3 minutes, so I'll try to go over, but, yeah. So this is a model of San Francisco that we have created. If we're talking about scale, creating a full city, this is not Google Maps. This is Cognata. So how much time do we have, Ron? 2 minutes? I will try to take 1 minute, and then I will take questions. Another thing that is quite unique about Cognata, I've been using simulations for years. It was all like very unfriendly software. And since Cognata is like you had to edit an XML and create the environment yourself and all of this stuff, you need like an army of engineers to do one scene. Nobody needs like something like that. So since Cognata is built out of real maps, we're using actually Google Maps. You want to go from point A to point B, you just point on a map, it calculates it with Google Routes automatically. You want to place sensors, put them virtually with a web-based interface. You want to add some behavior of pedestrians that you don't have any data for, so we're using heat maps. You can tell how many, what would be the density, how good they are. Would they cross the street on a red light or cross it at the middle, etc. And the idea with Cognata is to create a scenario or like multiple scenarios with a few clicks. Now we'll take questions because we don't have enough time. Sorry.
Simulation and everything tends to be pretty much perfect. So do you think your simulation is also good for teaching network and then using it, or only for testing?
So we tested the data that we are creating, and it proves to be very close to the real data. What we say is that the right mixture is to have a lot of simulated data and some data that you take outside.
Because according to what Dan said before, when you train your network based on simulation, it doesn't translate very well.
Right, because you don't have like the quality that we have. Taking data from GTA gets you to drive a GTA. Yeah.
So you say that you use real data from real cameras to create the simulated data. So the question is, do you still need this vast amount of real data to create simulated data or not? And how do you know you cover all the scenarios?
So we can tell, we're quite confident, that having hundreds of hours of imaging get us to very close to all the algorithms which are installed in your camera, including the ISP and the dynamic range. So again, we're not trying to be 100% accurate, but we'll get you to top 19s in terms of quality.
How you simulate the weather conditions?
Of course.
How?
This is like, the nice stuff about OpenGL, Foggy, all of those, and then after we have all of those rendered in the software, we apply DeepNets to get it rendered on the right camera profile.
Just one more question, otherwise you will have simulated lunch.
Yes, please.
Just to add that Google dropped the support of the Google Earth API.
Google Earth API.
Yes.
So we use not only Google Maps, we use it, more as a UI and a way to calculate real routes when we are mapping a city. So going from point A to point B would make sense.
So you don't need to use the...
No, it's like a nice way to a user interface and a way to, have some shortcuts in terms of creating the scenarios.
Thank you very much.
No problem. Thank you.
Thank you.